Hello, Algebra 2, Part 2 of our Semester 1 review for our semester exam. Alright, number 9. All we got to do is check out what's going on inside of our problem and make sense of it over here. We got costs for parts. Our labor is going to be $70 per hour. Per being our important word here, per meaning multiply. So I need 70 times something, not 70 plus or 70 minus. I need 70 times n here. Now, if you go get your car repaired, are they going to take away the price of your parts, or are they going to add that to your bill? They are not going to take away the amount of cost for your parts. It's not going to happen. If you find a place that does that, let me know, and that's where I will take my truck next time I break something in there. Alright, which one of these relations is a function? We might want to remember that a function is never going to repeat the input without repeating the output. So every time you see two numbers here that don't match two numbers here, that is not our answer. Those are just relations. Two numbers here don't match here. Two numbers here don't match here. Nothing is the same on the left side, so that means that is our answer. This one is a function, as far as we know. Alright, domain. Long story short, domain and range. We've got input, we've got output. We've got x, y, or f of x. Domain is always talking about things that are moving left and right on graphs. Range is always talking about the ups and downs inside of our graphs. But more importantly for this particular problem, we got domain comma range. So when it asks us for domain, we're just asking about the first numbers of each one of these coordinates, and then find them in your answer. Should be one of the easiest questions on the entire final, but somebody's going to miss it. Somebody's going to choose these back numbers. Someone will just make them positive. Somebody won't listen or read or try. So that's where that goes. Alright, number 12. This one's a little bit different than what you're actually going to see on your test, so I'm going to work out number 12 for you real fast and then show you the way it's going to look on your actual test. Alright, look at that magicalness. I solved for y here to find out what my slope was, because parallel lines always have the same slope, which is why we're crossing these out. I plugged in my x and my y here to figure out what the back number b had to be. In this case it was 6. So that's that. But on your actual test, this is what they're going to have you do. Take 2 points and find the line through those 2 points. So we need to use our slope formula of the y minus y over our x minus x. Now, you'll know from me at least that I don't care what order you put them in, as long as you go the same order both ways. I need my y's on top. That's going to be my 2 and my 7, so I'm going to go with negative 2 minus my negative 7. Remembering that both these negatives need to be in here, the one from our problem and the one from our point. X is going to go on the bottom. Since I went with my 2 first, I got to go with the 4 first on the bottom as well. And my negative 6 here to make things match. Now we got a whole bunch of 2 negatives making positives here and here. 7 minus 2 is going to give me 5 on top, and 6 plus 4 is going to give me 10 on the bottom, which gives me a 1/2 for my slope. So that's half of my equation. I got the slope. We might remember the whole y equals mx plus b. Well, that's the 1/2 right there. Now we need to find out what is the b part of our equation. An easy way to do this without having my answer choices, because I just made this up, is to take one of our points. I'm going to pick this one, and I'm going to plug it in for my y and my x and see what happens. Negative 2 equals 1/2 of that 4. Oh, I couldn't decide what I want to write there. I'm going to put it in parentheses. So I got 1/2 of 4 is 2, so I got negative 2 equals 2 plus b. I'm going to subtract that 2 from both sides and get negative 4 equal to my b. So that's part of it, that's part of it. Now I can write my whole answer out, y equals 1/2 x minus 4. And this is the basic process you're going to have to go through on your actual semester exam there in a few days. Number 13 is basically the exact same question we just did, only they're giving us more than 2 points, they're giving us 5 points. And they're all in order. So if you want to take these and use 1 comma negative 11 and 2 comma negative 14 and do this process, go for it. I'm going to show you a little bit easier way, because who doesn't like easier? Alright, so we're just going to treat this kind of like a pattern. What are we doing here? We're going from negative 11 to negative 14. We're subtracting 3, subtracting 3, subtracting 3 every time. So if I want to find out what's going to happen here, we're going to subtract 3 and get negative 26. Well, what does that mean for our equation? Well, if we're subtracting 3 every time, that's our slope, it's our rate of change. It's the repeated addition or subtraction, which means I don't want an 8 for my slope, I want one of these negative 3's. Now how do I find which one of these two numbers do I want, positive 8 or negative 8? What that is if I kind of forget these were here and put a 0 here, x, y, what would be in this part of the box if there was a 0? Well, pattern-wise, I'm subtracting 3 every time I go to the right, so if I'm going to the left, I'm going to add 3. Negative 11 plus 3 is going to make negative 8, so that means negative 8 would be the number here that would continue our pattern on along. That means I want my negative 8 here for my y-intercept, our b part of the equation, and I'm going to select D for our answer. How many letters can I say in a math problem? Apparently quite a few. Number 14, just finding our slope. Please, please, please remember, lines that look like this are positive, lines that look like this are negative. You know, doing that kind of a thing. If I was standing here, am I going to go up or down? I'm going to slide downward. That's a negative slope. So don't choose these ones. We've got to at least get to this kind of a situation where we know positives and negative slopes. Now to find our actual slope, we just need to be able to count and find 2 points to count from. 2 points that go right through our graph. Always go from left to right, and as I go downwards, it's a -2, and I go to the right, I'm going positive 3. So I want a slope of negative 2 over 3, right here, answer B. Alright, 15. 15's scary because there's all kinds of numbers, all kinds of stuff to read. It's not that bad. Just think about things. Well, first decision, positive or negative. Is our temperature going to be going up or is it going to be going down? Well, from 79 degrees at 10 a.m., it turned into 103 degrees at 4 p.m. Well, did the temperature go up? Yes. So don't pick a negative number for your answer. If you're going to just blindly guess, at least read the question and take a good guess. So now all we have to do is just kind of, what's 103 minus 79 on top, and from 4 p.m. minus 10 a.m. on bottom. 103 minus 79, what's that, 24? And from 4 p.m. to 10 a.m., if you can't do that kind of subtraction, just count. 10 goes to 11, goes to 12, and goes to 1, 2, 3, 4. So how many hours is that? That is 6 hours. And when I divide that, I'm going to get 4 degrees per 1 hour. And C is our final answer. It's not that bad. You can do that problem. Alright, number 16. This is another one that's a little bit different than what they ask us for, or ask us to do on our actual exam. Which line is perpendicular to this line? Well, I want to solve that for y. So 3x minus y equals 4. I'm going to subtract that over here, get negative y equals negative 3x plus 4. Nobody likes a negative y, so I'm going to change that to positive and negatives here. So my slope is a positive 3 over 1. Perpendicular slopes, you might remember, are negative reciprocals of each other, which means we need to flip it over and change the sign. So I'm going to flip it over, 1 over 3, change the sign, make it negative. Which one of these has a negative 1/3? This guy right here. Yeah, that's Mr. Dunker there. He says hello. Hopes you guys are doing well. Alright, our alternate, number 16 here. This is what they're actually going to ask you to do on our real test. So what we need to do here is we need to solve both of these for y. We need to turn them into y equals. We're going to add or subtract the x and divide by the number in front. I'm just going to do that real fast for you because I can. Alright, so here we go. I solved them both for y. We added the 2x here divided by 3, and I really am just looking for our slopes as we look at these things here. Subtracted my 6x divided by 4 and got my slope here. Well, if they're parallel, the slopes are the same. Are the slopes the same here? No. Coincident means every single thing is the same, and that's a no. Don't pick none of these. They're going to put that there. Just don't pick it. Perpendicular. Did the slopes flip over and change signs? Yes, they did. So perpendicular is our answer, and that's what they're going to ask you to do on your actual semester exam question. So be prepared. Alright, number 17. Last one on this little section of video. If we want to graph this line, there's a couple different ways. You can solve for the y and make it y equals and use your intercept and your slope. I'm going to go with the easy cover-up way. What's 36 divided by a negative 9? Well, that would be negative 4. So then I switch and I cover up the other side. Ooh, I moved that with it. Wasn't that fun? What's 36 divided by 4? Well, that would be y equals 9. So we want an x through the negative 4 and a y through the 9. Well, that's here and here. Well, so it's not A, it's not C, it's not D. That is B that goes through those 2 points for our y and our x intercepts. So that's a good review, but that's not what they're going to have you do on the test. They decided they wanted you to graph an absolute value equation. So let's kind of get a remembrance of what we do here. Positive in front means our v goes up. Negative in front means our v goes down. Alright, this number here is going to tell us whether we're going left or right, but it's the one on the inside, so it's always opposite. Positive going to the left, negative going to the right. Our number on the outside is going to tell us what we're going up and down with our vertex. Positive is up and negative is down, just like it normally should be. So, in this particular case, this negative here means our v is going to go downwards. Positive here means we are going to move our vertex to the left, and positive here means we're going to move it up. So we're going to be looking for, on our actual exam, a v going downwards, where we're going to move 1, 2, 3 over, and 1, 2 up. So we're going to find this point here, and a v going downwards. And that's the basic idea there. So this is kind of your key. That looks really crazy, but I swear it makes sense. And that's all you're going to need to do on 17 on your actual semester exam. That's it for this part, so we'll see you over in part 3, where we take over at number 18.